Good evening. Now next I have started this chapter brake, and first lecture I have delivered to you. Now the next one is I will take up this type of brake, right? Type of brake. Brakes कितने टाइप की होती हैं, and that I will explain it and design the equation of the brake also. So first of all I will write here types of brake. So types of brake. Types of brake. This is your lecture number 2nd. So then the brakes are classified according to this. Brakes are classified. Brakes the types की होती हैं. This is classified as hydraulic brake and electrical brake. That is hydraulic brake, electrical, hydraulic brake, electrical brake. So the hydraulic brake is again, this is divided into two parts, right? This is divided into two parts, that is pumps and this is your one, this one your pumps, hydraulic brake. This one is pump, hydraulic brake, and the second one is fluid agitator. Fluid agitator. Fluid agitator. So hydraulic brakes, they are having two parts, that is pump, hydraulic brake, and fluid agitator. Whereas this electrical brake, this is eddy current brake. This is also having two parts, you can say eddy current brake, and the second one is generator brake, right? So electrical brake, this is also having two parts, but these brakes, they are not in syllabus. So what the brake we will take today, this is your mechanical brake. Main important is your mechanical brake. So the mechanical brake, this is divided in two parts, that is radial brakes. First we will say external brake and internal brake, and then the external brake and internal brake, and then this is your band brake or shoe brake. So this is divided in two parts, that is external brake and internal brake. External brake and internal brake. So this external brake, this is in two parts, that is radial brake and axial radial brake and axial brake, whereas This is your internal expanding brake. So this is your internal expanding, this is your internal expanding brake, right? So these, now you come to this radial brakes, because this is in our syllabus, so we will take this only. There is no need to write here. So radial brake जो है, radial brake this is two parts, that is shoe and band brake, right? Shoe and band brake, radial brake, right? So either you write down here shoe and this is your band brake. So this is your radial brake, right? Now I will discuss one by one. First of all, radial brake, you must understand it, why it is called, why it is said to be radial brake. So in radial brake, what happens? In radial brake, so actually this is your, in radial brake, this is your drum. You try to understand it. So this is your drum, right? And drum is rotating either clockwise direction or anti-clockwise direction. That depends upon its direction of the rotation. So here is your shoe, you can say. This is your shoe here. So this is shoe, right? So shoe is applying the normal pressure on this. This is your axis. So when the pressure is acting in radial brakes, what happens? When the pressure is acting, normal to this, normal to the circumference of this or normal to this, then when the pressure is acting radially to the axis, when the pressure acting radially to the axis, in the radial brake क्या होगा? जो pressure है वो axis के ऊपर radially act करेगा. When the pressure is acting radially to this, you can say when the pressure is acting like this, like this, like this, like this, when the pressure is acting radially, these brakes are called shoe brakes, right? These brakes are called radial brake. In the radial brake, pressure acts radially on the drum, right? Pressure acts radially on the drum, whereas in axial brake, the pressure acting actually on the drum, right? Pressure act along the axis on the drum. So this is your in axial brake. So you can say, I will write here, in radial brake, क्या होगा? The force acts on the rotating drum, force act on the rotating drum radially, force act on the rotating drum radially. So this is your radial brake. And in axial brake, the force क्या होगा, ड्रम के ऊपर जो फोर्स होगी एक्सियल ब्रेक में क्या होगा, फोर्स ड्रम के ऊपर जो फोर्स होगी एक्चुअली एक्ट करेगी, और जो आपका रेडियल ब्रेक होगी वहां पे फोर्स ड्रम के ऊपर रेडियली एक्ट करेगी. दिस इज ओनली द डिफरेंस इन द रेडियल ब्रेक्स एंड एक्सियल ब्रेक्स. सो इन एक्सियल ब्रेक फोर्स acts actually on actually on the drum, right? So जो रेडियल ब्रेक्स हैं आपकी, फोर्स एक्ट रेडियली ऑन द ब्रेक ड्रम. सो रेडियल ब्रेक्स आपका कौन सा आएगा, रेडियल ब्रेक्स में आपका शू ब्लॉक ब्रेक होगा एक, एंड द सेकंड वन इज योर बैंड ब्रेक. राइट. शू ब्लॉक ब्रेक और बैंड ब्रेक में जो आपकी फोर्सेस है ड्रम के ऊपर रेडियली एक्ट करेंगी, एंड टुडे आई विल डिस्कस दिस शू ब्लॉक ब्रेक एंड एज वेल एज बैंड ब्रेक. दिस आई विल टेक द डिजाइन इक्वेशन ऑफ दिस, and this is very important one also. You must try to understand, and this is very interesting also. If you will put the efforts and try to understand what because I will just use a very simple way to make you understand what is this. So first of all, I will take the shoe block break. So this is your drum, and suppose this is your drum and this is your Now you understand this. This is the diagram of your this shoe block brake here. What is this? This is your lever. This is your lever, and this is your rotating drum. The shoe is attached with the lever. What happens? Right? Shoe is attached with the lever. What happens when the drum is rotating? When the drum is rotating either the clockwise direction or the anti-clockwise direction. So our aim is to stop the drum. What our aim is to stop the drum. If we will apply the brake, the drum should be stopped. So for this purpose, what we will do that when we will apply the force on the lever, when we will apply the force on the lever and the lever will rotate about its hinge. This is your O, so you can say the lever will rotate about the hinge, and this shoe will attach with the rotating drum. This shoe will attach with the rotating drum. When this shoe will attach with the rotating drum, what happens? There is a relative motion because the shoe is static and the drum is rotating. So then there is a relative motion between the shoe and the drum. There is a relative motion between the shoe and the drum, and frictional force will produced between the contact surfacing of the shoe and drum. That friction force will oppose the rotation of the drum. That friction force will oppose the rotation of the drum, and this friction force will, what happens? This friction force, suppose if I will say this is your radius R of the drum. So this friction force will act to the center, and the torque will produce, torque will produce, and that torque will break the rotation of the drum. So this is actually about this, that what is the method, and I will just explain you in detail about the working principle of this. But simply I have told you, here is a rotating drum. Its construction is like this. This is a rotating drum, and we want to stop this rotating drum, and this is your lever. This is your lever. This is your lever, and lever is attached to this hinge. This is your hinge, and lever is attached to the hinge. So what happens? Because when the drum is rotating and we want to stop the drum, what happens? We will apply the force. We will apply the force on the lever, and the shoe will attach to this drum. When the shoe will made to contact with the drum, or it is attached with the drum, what happens? There is a frictional force developed between the shoe and the drum, and that frictional force will stop the rotation of the drum. This is about this. Now, before going to the design equations or before going to the working of this, I just want to explain you. First, I will take the free body diagram of this and first explain when the shoe will attach to this. So, what types of the forces are on the shoe and what types of the forces on the drum, right? Suppose if I will draw the free body diagram of this. Suppose this is the free body diagram. This is your, try to understand it, I am just explaining you. This is your rotating drum, you can say this is your rotating drum, right? And this is your shoe. This is your shoe. is your shoe. This is your rotating drum and this is your shoe. This is the rotating drum. First of all, before going to its working, before going to its working principle or the design equation, first you try to understand what are the forces will act on the shoe and the drum, right? So first we will say that when the shoe will attach to this drum, what happens? Drum will apply the perpendicular force, that is normal force on the shoe, or you can say drum will apply this force like this and the shoe will apply the force on the drum. So this is Rn, this is Rn. This force is from the drum to shoe, and this is from shoe is applying the force to the drum. This is according to the Newton's third law of motion. Equal and opposite forces are acting like this. So फर्स्ट फोर्स तो ये ड्रम जो है ये शू के ऊपर ये लगाएगा और शू जो है ड्रम के ऊपर इस तरीके से ये फोर्स एक्ट करेगा, राइट। नेक्स्ट कौन सा होगा? जब इसको हम इसके साथ अटैच करेंगे, व्हाट हैपन्स? सपोज इफ आई से दैट द ड्रम इज रोटेटिंग टूवर्ड्स द क्लॉकवाइज डायरेक्शन. Suppose that drum is rotating towards clockwise direction. So what happens when it will attach to this? Because the motion of the drum is to be stopped when the shoe will in contact with the drum. So then there is a force, frictional force developed on the drum, and this frictional force, you can say this is in your Ft, this is in your opposite direction of the rotation. This is in the opposite direction of the rotation. You understand this? So same way, if this force is in the opposite rotation, so same way the force will act on the shoe. This is Ft also, same magnitude of force will act on the shoe, and that is in the same direction as the rotation of the drum. That is on the same direction as the rotation of the drum. So these forces will act on the shoe. One is the normal force which shoe is applying to the drum and drum is applying to the shoe, and the second one is the braking force Ft, which is perpendicular to this normal force, This Ft is the this and Ft is the frictional force which is opposite to the rotation of the drum, and this is in the opposite directions of the rotation. And there is one more force is there, that force will act on the shoe. This is also Ft, but it will act in the same direction of the rotation of the drum, right? So these forces will act on the shoe, this. So after that, now I will take the working of this. So this is all about you, which I have given you, that how these forces will act on this drum and shoe. And naturally this Ft will create what? The Ft will create the torque at the center of this, which will retard the motion of this, and that torque is called the braking torque. This I will explain you later on. But these are the forces. First you will concentrate yourself on the forces, that the shoe will apply these forces and the drum will apply these forces, and these are the forces, right? So the next one is, if you know, I will say the working principle. Working principle. So as I have already told you, as this, suppose this is your drum and this is moving towards clockwise direction. This is rotating. The drum is rotating towards clockwise direction, right? So in order to stop the rotation of the drum, what I will do in order there is a lever. There is a lever which is attached to this hinge at this point O, and with the lever this shoe will be attached. Now I will press the lever, means the force is applied on the lever. When the force is applied on the lever, this force is also called the braking force. This I will tell you later on. But when the force is applied on the lever, what happens? The lever will rotate about the hinge hole. The lever will rotate about the hinge hole, and this shoe will be in contact with your rotating drum, right? Shoe will be in the contact of this rotating drum. As the drum is rotating and the shoe is stationary, shoe is static, drum is rotating. But when it is in contact with the rotating drum, what happens? There develop a frictional force between the shoe and the drum on the contact surface, right? जहाँ पे क्या होगा, shoe और rotating drum के बीच में frictional force develop होगा, and that frictional force, this I have already told you, that frictional force जो होगा वो drum के ऊपर in the opposite direction of the rotation होगा. अगर इसका rotation जो है clockwise है, जो frictional force इसके ऊपर होगा that is in the opposite direction. So you can say so frictional force is Ft. This is in the opposite direction of the rotation, and this frictional force will produce the torque at the center, and that torque will stop the rotation of the drum. That is called the braking torque. And the force, the quantity of the force which is applied here to stop the drum, that force or P is called the braking force, right? ये आपको समझ आ गया? Now it is clear to everybody. If there is any problem, tell me now. Again I will tell you, the working is very simple. As the drum is rotating towards the clockwise direction or anti-clockwise direction, whatever it is. So whatever the direction is, when we apply the force on the lever, what happens? The lever will rotate. The lever will rotate on its hinge, and the shoe will be attached with the rotating drum. When the shoe will attach with the rotating drum, what happens? The shoe is static, drum is rotating. What happens? Due to this, the frictional force will develop between the shoe and the drum, and that frictional force will be in the opposite direction, which will stop the rotation of the drum. This frictional force, anyway, this frictional force will produce the torque which is called the braking torque, and that torque will stop the rotation of the drum. So this is about your working principle of this. I think everybody has clear now. I think there should be no problem, and if you are confirmed to this, then I will move on further. Right. Next, no, I will. So one definition is braking force. Braking force क्या है? What is braking force? The force which is applied to stop the rotation of the drum. The force applied to stop the rotation of the drum, that force is called as braking force. समझ आया? जो हम जहां पे लीवर के ऊपर ये फोर्स जो अप्लाई कर रहे हैं, और ये हम उतनी फोर्स अप्लाई करेंगे जिससे जो आपका ड्रम का मूवमेंट है वो स्टॉप हो जाए. वो जो फोर्स होगी, द फोर्स अप्लाइड टू स्टॉप द रोटेशन ऑफ द ड्रम, दैट फोर्स इज कॉल्ड द ब्रेकिंग फोर्स. दैट फोर्स इज कॉल्ड द ब्रेकिंग फोर्स. एंड लाइकवाइज द ब्रेकिंग टॉर्क, दिस इज अ वेरी इंपॉर्टेंट term, these two are very important term, braking force and braking torque in the design equation of this brakes. So braking torque, this is TB. The torque developed due to the frictional forces, the torque developed due to the frictional forces to stop the rotation of the drum. That torque is called the braking torque. The torque developed due to the frictional force on the drum. The torque developed due to the frictional force on the drum to stop the rotation of the drum. That is called braking torque. So these are the two important terms. So here you can say braking torque is this T is equal to T is equal to Ft. Ft is the frictional force and R. So this is your braking torque, Ft into R. So these are the two important terms which we use in the design equation of this. So I think you understand now what is braking force and the braking torque. Now the next one is the shoe, which we use here in case of this. So there are two types of shoe. So you can say there are two types of shoe, and I will take one by one. There are two types of shoe, two types of shoes. There are two types of shoe. One is your short shoe or small shoe, and the other one is your long shoe. So one is your small shoe or short shoe, and the second one is your long shoe. So as per there, you can understand one is small shoe and one is long shoe. So what small shoe और long shoe, इसमें जो पैरामीटर्स हैं वो डिफरेंट हो जाएंगे. So I will explain this long shoe and small shoe. What is this? First I will take small shoe. देखिए जो आपका स्मॉल शू है, सपोज दिस इज योर शू, this is your small shoe. So this is your small shoe. So small shoe में क्या होगा? फर्स्ट ऑफ ऑल क्या होगा इसमें जो फोर्स होगी वो इस तरीके से एक्ट करेगी. So as the cross sectional area, as it is very small one, so its cross sectional area is also small. The pressure force is acting on this shoe. But here we will say that as the area is very small, cross section is very small, so we will assume that the pressure force which is acting on the small shoe, that is acting on the center only, and that is only a single force. That is only a single force. So you can say pressure force, this is only a single force which is acting on the center of this in case of small shoe. And the second one is, in case of small shoe, we will take angle that should be less than 45 degree, or angle should be 45 degree or less than 45 degree in case of small shoe. The angle should be 45 degree. But here, in case of long shoe, what happens? Here we can take, in small shoe, we can take only a single pressure at the center. We will take the single pressure at the center, means we will take simply single pressure on the center. That is the normal force, that is Rn in case of small shoe. What in case of your long shoe? What in case of your long shoe? There is also pressure forces are acting here on this. What happens? This pressure force is like this. As the cross sectional area is much, so the area of contact is also much here. So we will say the pressure forces on the center is maximum. So here you can say सेंटर में P आपका मैक्सिमम होगा और जो आपका साइड है वहां पे P आपका मिनिमम होगा, राइट? P मिनिमम एट द साइड, और जहां पे सेंटर में P मैक्सिमम प्रेशर होगा, जबकि इसका एरिया ज़्यादा होने के कारण, इसका कांटेक्ट एरिया ज़्यादा है क्योंकि ये लॉन्ग शू है, इसका एरिया, इसलिए हम इसको एक सिंगल फोर्स के में कंसिडर नहीं करेंगे. वी विल नॉट कंसिडर इट टू ए सिंगल फोर्स लाइक दिस you can say small shoe. Here we have considered it as a single force here, which is perpendicular to the center of this. But here we will not consider it as a single force because the P maximum, its area is maximum, its cross-sectional area is maximum, its area of contact is maximum. So the P maximum is, pressure is maximum at the center and minimum at the corners, right? So this is the difference. And here the theta is greater than 45 degree. जो आपका थीटा है वो 45 डिग्री से ज़्यादा होना चाहिए. बट हेयर वी विल नॉट टेक, जो एंगल ऑफ कॉन्टैक्ट है, वी डोंट टेक थीटा, वी टेक 2 theta. Angle of contact we take 2 theta. So to make the equation easier, we can take theta also, but when we will take theta also, then the equation will not be easier. It becomes theta by 2, and then the calculation is somewhat difficult. But here in case you can say angle of contact angle of contact, this is angle of contact, angle of contact 2 theta, right? So in case of long shoe, the angle of contact should be greater than 45 degree. Some books they have referred the angle of contact should be greater than 60 degree. But I will take that the angle of contact here in case of small shoe, that should be 45 degree or less than 45 degree, and in case of long shoe the angle of contact should be 45 degree greater than 45 degree, right? So angle of contact is denoted by, angle of contact is denoted by 2 theta, right? So this is the difference in small shoe or short shoe and long shoe. There is only one difference here. First we will say that the angle of contact that should be 45 degree or below 45 degree in case of small shoe, and in case of long shoe the angle of contact should be greater than 45 degree. And the second one is, so definitely if the coefficient of friction here is mu, suppose if the coefficient of friction here is mu, So the coefficient of friction of this long shoe, that is greater, and its equation is mu dash is equal to 4 sin theta 2 theta plus sin 2 theta. So this is the coefficient of rest. Every equation is same. Rest every equation is same. Only the difference is this, because if we will take Ft, as you know, Ft is equal to mu into Rn. Ft is equal to mu into Rn in case of this small shoe, right? So in case of long shoe, you replace mu with mu dash. You replace mu with mu dash, and the value of mu dash is equal to 4 sin theta So the value of this, right? So the torque इसमें क्या हो जाएगा? As in this case of this small shoe, torque is T is braking torque is equal to Ft into R, and if we will write in case of this, this is equal to mu into Rn into R. So in case of this long shoe, your braking torque is, rest everything is same, only you will use, instead of mu, you will use mu dash, and you calculate the value of first mu dash, 4 sin theta 2 theta plus sin 2 theta. So here the angle is given to you, 2 theta is given to you, and the angle of contact is given. So you substitute. But one thing you have to remember also, if you will put angle of contact here, suppose it is given you 2 theta 60 degree, right? Suppose if the 2 theta is 60 degree, so therefore theta is equal to 30 degree. And when you will, sometimes it is a confusion, and some students actually will not properly do it. What happens, they write on theta, जहाँ पे theta होगा, sin के साथ जहाँ पे theta होगा, वहाँ पे तो आप डिग्री में इसको जहाँ पे सब्स्टिट्यूट करेंगे. लेकिन जहाँ पे थीटा नहीं है, जैसे इन केस ऑफ दिस, देयर इज नो साइन कॉस और tan like this. So when there is no trigonometric function with this is simply theta here. When there is simply theta, then this theta should be in the radians. This is very important point, because in numericals sometimes you do the mistake. If you don't know, you just put all the values like this, third degrees में आप ये value put कर देते हैं, and this is the biggest mistake. So this you must remember it. What? That in case of when the theta with the trigonometric function, then you will use the theta in degrees only, right? And when the theta is independent, there is no trigonometric function with this, then the theta you will take in radians. This is the difference. And by substituting this, so TV is equal to means mu dash into n into r, right? R mu dash into n into r. So mu dash आप जहाँ से calculate करेंगे, and you will get the braking torque, right? So this is about your this long shoe and small shoe. स्मॉल शू में आपको जो म्यू की वैल्यू है, कोफिशिएंट ऑफ फ्रिक्शन की वैल्यू है, वो जो आपको दी होगी एज इट इज, यू हैव टू सब्स्टिट्यूट. बट इन केस ऑफ योर दिस, in case of your this long shoe, you will use this equation and then you calculate the mu dash and then you substitute here, right? Sorry, actually I've done mistake. So this is I just slip here 4 mu sine theta. So this value is mu dash, this is equal to 4 mu sine theta, 2 theta plus sine 2 theta. This is the value of mu dash, and by calculating the value of mu dash you will substitute here. So this is about your the difference of small shoe and long shoe. This is the difference. Now the next one is, we will come to the design equations. I think you have understood its working principle, and also about the shoes. How many types of shoes are there? Small shoe, long shoe, what is the difference there? So now we will come to its design equations. So डिज़ाइन इक्वेशन आ गया इसका, डिज़ाइन इक्वेशन ऑफ द ब्रेक. So there are 3 cases here. इसमें 3 केसेस हैं. फर्स्ट केस है, केस फर्स्ट क्या है? व्हेन द फोर्स when the line of action of friction, when the line of action of frictional force passes through the hinge right. फर्स्ट केस आएगा when the line of action of frictional force passes through the hinge. This is the first case. Hinge of the lever, you can say hinge of the lever. So second case में आपका है, केस सेकंड क्या है आपका? जब फ्रिक्शनल फोर्स बिलो द हिंज पास करेगी, कहां? हिंज से, हिंज के बिलो से पास करेगी, वो केस आपका सेकंड होगा. व्हेन द फ्रिक्शनल फोर्स passes below the hinge. And the third one is जब फ्रिक्शनल फोर्स हिंज के अबव पास करेगी. हिंज आपका नीचे है, उसके ऊपर फ्रिक्शनल फोर्स पास करेगी. व्हेन केस थर्ड आपका आ गया, फ्रिक्शनल फोर्स passes above the hinge. So ये 3 कंडीशंस हैं जिनके ऊपर हमने इक्वेशन को डिज़ाइन करना है. These are the 3 कंडीशंस जहाँ पे हमें ये इक्वेशन डिज़ाइन करना है. तो पहले हम सबसे पहले ये केस लेंगे, ये वाला. तो इसमें मैं पहले इसकी डायग्राम बना लेता हूँ. So this is your first case. When the line of action of frictional force passes through the hinge of the lever, right? So this is rotating this side. Suppose if I will draw this free body diagram of this, first of all draw the free body diagram so that you can understand it properly. Free body diagram of the lever. Suppose this is your free body this is your free body diagram of the lever. The force P is acting here. तो दिस इज द फ्री बॉडी डायग्राम ऑफ द लीवर ड्रा करें हम जब, दिस इज अ फ्री बॉडी डायग्राम ऑफ लीवर टू कैलकुलेट व्हाट आर द फोर्सेस हियर। तो जहां से जहां तक डिस्टेंस तो आपको पता है, दिस इज योर डिस्टेंस L। तो क्या होगा, ड्रम जो है, जब ये शू ड्रम के ऊपर नॉर्मल रिएक्शंस, नॉर्मल फोर्स लगाएगा तो ये ड्रम जो है ये शू के ऊपर फ्री, एक तो आपने, क्योंकि आपने जो फोर्सेस कैलकुलेट करनी है आपने अब इसको भूल जाना है, ड्रम के ऊपर हमने फोर्सेस कैलकुलेट नहीं करनी है। वी हैव टू कैलकुलेट द फोर्स ऑन दिस शू ओनली, ठीक है। तो शू के ऊपर एक तो आर एन जे होगा, right, and if the frictional force of the rotating drum, frictional force आपका इस डायरेक्शन पे है, if the drum is rotating to the clockwise direction and the frictional force this is the anti clockwise direction, तो जो लीवर के ऊपर है वो फ्रिक्शनल फोर्स आपकी कहां पे होगी, इन द सेम डायरेक्शन, जिस डायरेक्शन के ऊपर आपका ये रोटेट कर रहा है। तो इसका मतलब लीवर के ऊपर एक फोर्स आपका P है, एक आपका Rn है, एक आपका Ft है, और इसके ऊपर अब हिंज के ऊपर भी रिएक्शंस होंगे। सपोज ये आपका रिएक्शन Rx है एंड दिस इज योर रिएक्शन Ry, राइट। सो दीज आर द फोर्सेस which are acting on the lever only, right? These are the forces which are acting on the lever only. So this is the free body diagram. Now consider as first case हम इसमें लेंगे, first case क्या होगा, when the rotation is clockwise rotation, when the drum is rotating clockwise direction and condition is which, what condition is what, this, that the line of the action of the force is line of action of the force passes through the hinge O or passing through the fulcrum O, ठीक है ना। line of action of force क्या है, वो fulcrum O से पास करेगी। so this is the first case and the drum is rotating clockwise rotation. so when the drum is rotating clockwise rotation, now you come to this, what we will do, we cannot take the sigma fx, we cannot take the summation of the sigma fx to calculate the value of P, because we have to calculate the value of P, force applied. So sigma fx क्यों नहीं लेंगे, because we don't need this Rx, we don't need the reaction Rx here. So likewise we cannot take this sigma fy also not here, because sigma by, if we will take sigma by, then we have to take this Ry also. So what happens? What we will do in this case, taking the moment about the hinge O, taking जब आप मूवमेंट को लेंगे हिंज के ऊपर, दिस इज योर हिंज O है और इसी के ऊपर ये रिएक्शंस हैं Rx एंड Ry, taking the moment about the hinge O and sigma of the moment on hinge, this is equal to 0, this equal to 0. So what happens? This force, this reaction force Rx and Ry, ये अपने आप क्या होगा? ये 0 हो जाएगा, because when you are taking on the hinge, so ये आपका जब आप मूवमेंट लेंगे तो these forces ultimately that will be neglected, that will be 0. So इस केस में क्या करें? सिग्मा m hinge, movement of sigma about hinge, ठीक है, taking movements about hinge and equilibrium to 0, equilibrium to 0, राइट. लीजिए देखिए ये आ गया आपका P. तो P का जो मूवमेंट होगा जब हम हिंज के ऊपर मूवमेंट लेंगे, P जो है डाउनवर्ड डायरेक्शन है, तो P का मूवमेंट किस डायरेक्शन पे होगा? क्लॉकवाइज, राइट. सो Ft is passing through the center of the hinge. When the line of action of force is passing through the center of hinge, this is the condition ना. ये जो फर्स्ट कंडीशन है जिसके ऊपर कर रहे हैं हम इसको ड्राइव इक्वेशन को, क्या कंडीशन थी कि when the line of action of force passes through the hinge, so इसका मूवमेंट क्या होगा? 0 हो जाएगा, because the line of action passes through a hinge, so its movement is 0. अब बचा ये, तो इसका मूवमेंट क्या होगा? ये क्लॉकवाइज है and its movement is anti-clockwise, so minus, so its movement is P into L minus Rn, whatever you want to write. Suppose I write here N only, normal force. So N into A, this is equal to 0, right? P into L, this is a very simple one, because so I have taken because you have to take the forces on the lever only. You have to take the forces on the lever only and taking the moment about hinge ho. So P into L and Rn, this is anti-clockwise, this is anti-clockwise. So minus Rn into A. Suppose if this distance is your from here to here, this is A. So P into L minus N into A, this is equal to 0. Therefore P equal to L, this is equal to NA, and P is equal to N into A into L. समझ आया? When it is rotating clockwise direction, right? So the same condition is when it is rotating to the anti-clockwise direction. Only the change, where the change will happen? Only the change will happen in this frictional force. But the frictional force is passing through the hinge. So the design equation में कोई change नहीं आपका आएगा, because frictional force when we will take the moment about the frictional force, अगर ये आपका this is your clockwise rotation थी, if I will take the anti-clockwise rotation, तो जो ड्रम की फोर्स है वो ये हो जाएगी, और जो इसमें लीवर में फोर्स है, दिस इज योर दिस डायरेक्शन. सो व्हाट दिस फोर्स इज पासिंग थ्रू द सेंटर ऑफ हिंज, सो ओनली देयर इज चेंज इन द डायरेक्शन ऑफ द फोर्सेस, only there is change in the direction of forces, so that will not affect to your design equation, because these forces are passing through the center of hinge or its movement is 0. So when this drum is rotating anti-clockwise direction, at that time also this braking force P, or the equation of force P, braking force P, this is equal to N into A into L. So the same equation in both the cases. In both the cases, the equation is same. So there is no difference. This is the first case when the forces are passing through the center of the hinge. Now you come to the second case. In second case, you write on this, and now I will rub it, and because I am going to the second case, so you write on this, जहाँ पे देख लो आप इसको अच्छे तरीके से, and then we will take the second case. So in second case, सेकंड केस में देखिए आप, जे आपका हिंज है, एंड द व्हेन द फोर्स इज कंडीशन इज, क्या कंडीशन है इसमें, व्हेन द लाइन ऑफ एक्शन ऑफ फ्रिक्शनल force passes below the fulcrum O or hinge O. ये आपका लाइन ऑफ फोर्स है ड्रम के ऊपर. सपोज फर्स्ट केस में लूंगा, फर्स्ट केस क्या लूंगा मैं, व्हेन इट इज रोटेटिंग इन द क्लॉकवाइज डायरेक्शन. फर्स्ट केस है, फर्स्ट केस लेता हूं मैं क्लॉकवाइज डायरेक्शन. सो दिस इज योर फर्स्ट केस इज क्लॉकवाइज डायरेक्शन. here is your this force P lever on this, and its distance from here to here is, its distance is L, right? So this is your force N, right? This is force N on the shoe or N on the lever shoe, ठीक है ना? तो अगर ये क्लॉकवाइज है तो जो लीवर के ऊपर आपकी फोर्स होगी उसकी डायरेक्शन किस इधर होगी, उसकी डायरेक्शन होगी ये जो लीवर के ऊपर है. दिस इज द फोर्स ऑन द लीवर, Ft on lever you can say, because I will clear it. And on the drum this is in the opposite direction, because in the opposite direction to stop the rotation of the drum. To stop the rotation of the drum, what happens? The frictional force on the drum, that is on the opposite direction. So I have taken this opposite direction. Now this is your hinge. So you can say this distance from here to here, this distance is your B, right? And the distance from here and the distance of the normal force, you can say this distance is your A, right? This is your B and this is your A. Now first I am taking the condition clockwise direction. फोर्सेस मैंने इधर ड्रा कर दी हैं. क्लॉकवाइज डायरेक्शन में होगा, कौन सी फोर्स होगी? जो लीवर के ऊपर है, जो लीवर की फोर्स Ft है, दैट विल ऑन द सेम डायरेक्शन एज द ड्रम इज रोटेटिंग, ऑन द सेम डायरेक्शन वेयर द ड्रम इज रोटेटिंग. ड्रम इज रोटेटिंग क्लॉकवाइज डायरेक्शन, सो दिस फोर्स विल एक्ट लाइक दिस. Whereas the force on this drum Ft, this will be in the opposite direction. This will be in the opposite direction. So it is not passing through the hinge. This is your hinge. It is not passing through the hinge. It is passing below the hinge. This is the condition. This is the condition. Second case, what we are doing here. This is the condition when the line of action of forces are not passing through the hinge, but it passes below the hinge. So this is the case. It passes below the hinge. So we will take now. Again, the same procedure is that we will take the movement about the hinge, and that is equal to 0. So movement sigma m hinge, this is equal to 0, right? अब मूवमेंट ले लीजिए. ये जो आपकी फोर्स है, ये आपकी फोर्स है, दिस इज योर क्लॉकवाइज डायरेक्शन, राइट? P जो है आपका क्लॉकवाइज डायरेक्शन है. Ft आपका क्या है? Ft क्या है? Ft is your anti-clockwise direction, and N is also what? N is also anti-clockwise direction. So this is your P is your clockwise direction, this is your anti-clockwise direction, and this is also your anti-clockwise direction. So क्या होगा इसमें? आप O के ऊपर ले रहे हैं, this is P into L minus Ft, this is the distance. Ft का जो distance hinge से, this is B minus ft into v and this is your n है, this is n, this is what, this is also your anti-clockwise direction, this is n into a, this is equal to 0, right? ये समझ आया आपको? p into l minus ft into b minus n into a, this is equal to 0. But you know ft is what? ft is what? ft is mu into n. So we can write instead of ft, you can write mu into n. So therefore p into l minus mu into n into v minus n into a, this is equal to 0. And now p is p into l, this is equal to, इधर जाएगा ये, mu n b plus n a, right? Or this is equal to, p is equal to, n कॉमन ले लो, a plus mu v upon l. So p, this is equal to a plus mu v upon l. So if you will compare this equation with your first equation, when the line of action of force passes through the center of the hinge, at this case I think p you have calculated like this, n into a into l. And if you will compare both the equations, you will see here, so there is no use of this, because here you have to apply the more force. This is n into a upon l, and this is equal to n into a plus n into a plus n into mu v upon l. So there is no use of this, because more efforts we have to apply, more force we have to apply when the condition is like this, when the force, line of action of force passes below the hinge and the drum is rotating clockwise direction. At that case, more efforts we have to apply to stop the drum, right? So this is first case in this case. Now we will come to the second case also, when the rotation of the drum is, this is all about this. Now I will rub it. So when the rotation of the drum is in the anti-clockwise direction, जब आप रोटेशन ऑफ द ड्रम जो होगा आपका, इसी को मैं कंटिन्यू करूंगा और डायग्राम नहीं बनाऊंगा, ओनली दिस आई विल कंटिन्यू. तो ये सेकंड केस हम इधर से ले लेंगे. हम सेकंड केस क्या है कि जब रोटेशन ऑफ द ड्रम आपका एंटी क्लॉकवाइज डायरेक्शन, तो जब रोटेशन ऑफ द ड्रम आपका एंटी क्लॉकवाइज डायरेक्शन होगा तो जो लीवर के ऊपर, शू के ऊपर फोर्स है एफ टी, वो उसकी डायरेक्शन क्या होगी, ये, राइट? बिकॉज द frictional force which is acting on the lever, you forget about the forces on the drum, this I have already told you. You take the free body diagram of the lever, and the force on the lever is, when the drum is rotating anti-clockwise direction, then the force on the lever is in the same direction as the drum is rotating. So the force is this direction Ft, you understand? And the normal reaction force तो same ही रहेगा. This is your n, बाकी पैरामीटर आपके सारे सेम हैं, बाकी आपके पैरामीटर्स जो हैं, all the parameters are same. So again now taking the movements about hinge, this is for anti-clockwise direction. So for anti-clockwise direction, you see here, you have to take the movement about hinge m sigma m hinge, this is equal to 0, राइट। जे फोर्स तो आपकी सेम रहेगी क्लॉकवाइज डायरेक्शन में, राइट, और जे फोर्स आपकी एंटी क्लॉकवाइज डायरेक्शन में आएगी। बट दिस फोर्स the force Ft means force mu Rn, this will act towards the clockwise direction। ये फोर्स क्लॉकवाइज डायरेक्शन में हाँ so now this is your P into L, right, this is P into L minus N into A minus N into A प्लस Ft को हम म्यू N ले लेते हैं प्लस म्यू N इंटू V, दिस इज इक्वल टू 0। समझ आया ये? इस केस में देखो एंटी क्लॉकवाइज डायरेक्शन में केस में देखो, अगेन आई विल जस्ट शो यू द डायरेक्शन ऑफ द फोर्सेस एज दिस, बिकॉज वी आर टेकिंग द मूवमेंट अबाउट द हिंज ओ, दिस इज क्लॉकवाइज डायरेक्शन, दिस योर एन इज एंटी क्लॉकवाइज। Now the next condition is when the line of action of frictional force passes below the hinge. So clockwise direction to I have just explained you. Now next condition is when the drum is rotating, anti-clockwise direction. So let's first understand. So when the drum is rotating anti-clockwise direction, then what is the design equation of the brake? So first of all, this is your diagram. This is your drum and this is rotating anti-clockwise direction. So then the forces are here. This is your normal force, this is acting upward direction, and this is your Ft braking force, this is your Ft frictional force, this is in the same direction in case of lever, because the design again I have told you that the design what we are just taking the forces on the lever only, we are not taking the forces on the drum. Otherwise the force on the drum, this is the force of the drum, this is in this direction, frictional force of the drum, this is your this direction, this is the force on the drum and this is the force on the lever. So the force on the lever, frictional force on the lever, that is in the same direction as your drum is rotating, right? So these are the forces. So in this case, again you taking this is your hinge, and you have seen that the force is below the hinge, line of action of force is below the hinge. So in this case, taking moment about hinge, that is sigma m hinge, this is equal to 0. So this is your which moment? This is your clockwise movement, the force P which is acting on this, and it will rotate the lever, the force P, this is in the clockwise direction, and this force, normal force about the hinge, because we are taking the movement about the hinge, so then the normal force, this is your anti-clockwise direction, and the force, this Ft, the force, this is acting your this clockwise direction. So this is the movement direction of the force. Now you see that this is P, and the distance from L, distance from the P to hinge, this is equal to L. So this is equal to P into L. Now you come to this N into this distance is how much? From the hinge, this distance is A. This is N into A, that is minus, because the movement is anti-clockwise direction. Clockwise movement we are taking positive, so anti-clockwise movement we are taking negative here. So this is N into A, and now you come to this Ft. Ft is below this, so its movement is clockwise, its movement about hinge, this is about clockwise, so this is plus Ft into the distance is A, the distance is, this is A, this distance is not A, this is B, this distance is B. So this is Ft into B, this is equal to 0, right? So what now? This is now the equation of the design becomes PL, this is equal to NA minus Ft is what? Your Ft is mu Rn, so this is mu N, because I am denoting this N, so it is N, mu N into V, right? So therefore P is equal to N, you take common, this is A minus mu V upon L, right? So this is the design equation in case of this when the drum is rotating anti-clockwise. Now just see the difference here. This is your design equation, P is equal to N into A minus mu V upon L. So if you will compare this design equation, you have this equation when the force passes through the hinge, that design equation we have calculated, this is P into NA upon L, right? And in case of the same condition, in case of this condition, the design equation we have calculated, and when the drum is rotating clockwise direction, the same condition, the drum is rotating clockwise direction, you see first the derivation which I have earlier done it. So the derivation is that when the drum is rotating clockwise direction, at that time P is equal to N into A plus mu V upon L. So these the two equations, I think. So if you compare, first you compare this equation, you first compare this equation from this equation. So you will see here the effort, here the force P which is applied on the lever or the braking force, this force is N into A upon L. What if you will compare this, if you will look to this equation, here you will see there P is equal to N into A minus mu V upon L, right? So from this equation and from this equation you will say that the effort P is reduced here. Effort P, the force P which we were applying on the lever to apply the brake, so the force P in this case is reduced. force P is reduced, right? So when the force P is reduced, it means we have to apply the minimum efforts. We have to apply the minimum efforts. We have to apply the minimum force on the lever to apply the brake or to stop the drum. But in this case, we have to apply the more force. P is equal to N into A upon L. So in this case, we have to apply the less force. And how it happens? ये कैसे हुआ? How it happens? Because here you will see from this diagram, here you will see that the movement is also applying the clockwise movement, whereas this your Ft is also applying the clockwise movement. So both are applying the clockwise movement. It means that Ft, this is helping the effort P to apply the brake. So this is also helping because this is in the same direction, that is clockwise direction. This is in the same direction, the clockwise direction. So Ft is helping the P to apply the brake. So you can say braking effort has been increased. In this case, the braking effort has been increased because Ft is also helping the P to apply the brake. So braking effort has been increased and the value of P is considerably reduced. So such type of brake or what? ऐसी brakes को क्या कहते हैं? Such types of brakes are called the energizing brakes. So these are the energizing समझाया? The brakes are energizing. So brakes are energizing means here you have to apply the minimum effort because the Ft is also rotating in the same direction and it is also helping the P to apply the brake. So definitely the efforts of P will be reduced. So these types of brakes are called the energizing brakes. अब इसमें एनर्जाइजिंग ब्रेक्स का मतलब ये है कि P की वैल्यू आपकी लेस है, P की वैल्यू लेस. अगर आपकी P की वैल्यू बहुत ज़्यादा आप लेस कर देते हो, P की वैल्यू रिड्यूस करते करते बहुत ज़्यादा लेस करते हो और अगर आपकी P की वैल्यू 0 हो जाती है, सपोज इफ द वैल्यू ऑफ P इज 0, so then it means that the efforts which you are applying itself, you are not applying any efforts, you are not applying any force. It means that brake is not under your control. This is not under your control. So this is a very dangerous position. So such type of conditions when arises, if the efforts P or the value of P is equal to 0, such types of brakes are called the self-locking brakes. So such types of brakes are called self-locking brake. Self-locking brake. समझ आया self-locking brake क्या है? Again I will explain you. Here in case of self-energizing brake, your self-energizing brake है आपकी. This is your self-energizing brake. So self-energizing brakes में क्या है कि P की वैल्यू आपकी रिड्यूस होती है, तो एफर्ट्स आपको कम लगाना पड़ता है क्योंकि आपका जो मूवमेंट्स, इसका P का मूवमेंट्स है और Ft का मूवमेंट्स है, बोथ आर एक्टिंग इन द सेम डायरेक्शन. सो वन कंडीशन ऑफ सेल्फ एनर्जाइजिंग ब्रेक्स की ये भी कंडीशन आप लिख लीजिए, व्हेन द मूवमेंट्स ऑफ P एंड द मूवमेंट ऑफ Ft both are acting in the same direction, then the brakes are called self-energizing brakes. So here the effort P it has been reduced, but if it is reduced considerably and at one point if you say your effort P this becomes 0, so when your effort P becomes 0, it means the brakes are not under your control. So that brakes are called self-locking brakes. they are not under your control. So such a very vulnerable, very dangerous position, so you need some value of P, there should be some positive value of P, there should P should not be equal to 0. So in order to avoid the self-locking brake, so you can say in order to avoid self-locking, what should be there? P should be greater than 0. So in order to avoid self-locking, P should be greater than 0, or you can say A minus mu V, that should greater than 0, or you can say A should be greater than mu V. ठीक है, ये कंडीशंस हैं इन केस ऑफ अवॉइड सेल्फ लॉकिंग. P शुड बी ग्रेटर देन 0. P कभी 0 नहीं होना चाहिए. अगर P 0 हुआ तो ब्रेक आपकी सेल्फ लॉकिंग हो जाएगी, और जब ब्रेक सेल्फ लॉकिंग होगी तो ब्रेक आपके कंट्रोल में नहीं रही. तो दिस इज द डेंजरस पोजीशन. सो इन ऑर्डर टू अवॉइड सेल्फ लॉकिंग, P शुड बी ग्रेटर देन 0 और A माइनस म्यू V ग्रेटर देन 0 एंड A should be greater than 2 mu V. So this is about your when the line of action of frictional force passes below the hinge. Now the third condition, now we come to the third condition, when line of action of frictional force passes above the hinge. पहले हमने कौन सा किया? जब ये हिंज से लाइन पास करेगी फ्रिक्शनल फोर्स की, उस वक्त हमने दो केस लिए आपके, क्लॉकवाइज और एंटी क्लॉकवाइज, और उसमें हमने इक्वेशंस डिजाइन किया. सेकंड केस है कि सेकंड केस में हमने क्या लिया कि जब आप लाइन ऑफ एक्शन ऑफ फोर्स जो है हिंज से नीचे बिलो होगी तो उस केस में क्या होगा. और थर्ड केस आपका है कि जब लाइन ऑफ एक्शन ऑफ फोर्स जो है वो हिंज के ऊपर होगी और हिंज आपका नीचे होगा. एट दैट केस, so this is the third case, so which I will drive the design equation on this case now. So just see it now. So condition number 3. So condition number third, case third, when the line of action, of force means frictional force, you will say frictional force passes above the hinge. जब ये हिंज के ऊपर पास करेगी तो उस केस में क्या होगा, इसका डायग्राम वी हैव टू फ्रेम द डायग्राम अगेन. So this is your lever. Say this is your hinge. This is your hinge. This is your hinge O. first condition is drum lever So first condition I have taken when the drum is rotating clockwise, direction. So when the drum is rotating clockwise direction, so what happens? Again the same thing, only the difference is that the force is acting above the hinge. This is your hinge and this is your frictional force on the drum as well as on the shoe. So it means this is on above the hinge. So this is the condition, this is the case third. So on this case third, when the force is acting above the hinge, then we have to take the two conditions, that is clockwise directions, when the drum is rotating clockwise direction and when the drum is rotating anti-clockwise direction. So first condition I have taken when the drum is rotating clockwise direction. So this moment of P, this is your clockwise. Now the movement of this end, this is your anti-clockwise, and movement of this is equal to clockwise, right? So these are the conditions. So therefore, again taking moments about hinge and sigma m hinge, this is equal to 0. ठीक है. तो इक्वेशन क्या बनेगा इसका, सॉरी दिस इज दिस आई हैव नॉट रिटन, सो दिस डिस्टेंस इज योर L, the distance of P from hinge, this is your L, so it means that P into L clockwise. Now you come to this N, normal force, this is your hinge, this is your anti-clockwise, it will rotate like this is your anti-clockwise, so it means that minus N into A, and then you come to this mu Rn, this is your clockwise, so plus mu Rn, not Rn but mu N, I have taken N here only, so you write down N, not Rn, so write down N here only, so mu N. So this is equal to what? 0, right? Therefore, P into L, this is equal to N into A minus, sorry, mu N into B, this I have not written, mu N, this mu N, and this distance is how much? B. So this distance mu N into B, this is equal to 0, right? So PL is equal to N into A minus mu N into B, so this is equal to P is equal to N into A minus mu V upon L. So this is the condition. Again, this is the self-energizing brake. Here you see, again, if you will compare this your brake, suppose this one P is equal to NA into L, so here the effort P is reduced considerably here. So this is your self-energizing brake, self-energizing brake, self-energizing brake. And as I told you, you can see here also the P is rotating clockwise direction. The movement of P is the clockwise direction. And now you come to this movement of Ft, this is also clockwise direction, and when the movement of P and the movement of Ft both are in the same direction, then you can say your brake is self-energizing brake. So rest of the conditions I have already explained you in the previous topic, that all the conditions are same. So this is your self-energizing brake, right? So if वही सेल्फ लॉकिंग के केस में वही आ गया आपका कि इन केस ऑफ सेल्फ लॉकिंग व्हाट विल यू विल डू, कि सेल्फ लॉकिंग के केस में अगर आपका सेल्फ लॉकिंग केस, इन केस ऑफ सेल्फ लॉकिंग के केस में क्या होगा, अगर आपका P जो है वो 0 हो जाएगा तो ब्रेक आपकी सेल्फ लॉकिंग हो जाएगी। तो इसको अवॉइड करने के लिए हमें क्या करना पड़ता है, P ग्रेटर देन 0, P हमें 0 से बड़ा लेना पड़ेगा, so that your brake is not self-locking. So this is your when the drum is rotating clockwise direction. Now the second case I will take when the drum is rotating anti-clockwise direction, right? So when the drum is rotating anti-clockwise direction, save the time, actually I have changed the diagram here only. Otherwise again I have to draw it. So to save the time, I just change it. So when the drum is rotating anti-clockwise डायरेक्शन, तो जब आपका ड्रम जो है एंटी क्लॉकवाइज डायरेक्शन रोटेट करेगा तो उस वक्त फोर्सेस की क्या पोजीशन होगी, अभी बनाते हैं. जो सी है योर एन, ये तो आपका सेम रहेगा, एन इज एक्टिंग लाइक दिस, सो योर एन, सो दिस इज योर एन. सो ड्रम आपका क्या है, एंटी क्लॉकवाइज डायरेक्शन में रोटेट कर रहा है ऐसे. जो जब ड्रम आपका एंटी क्लॉकवाइज रोटेशन में रोटेट करेगा तो आपका जो एफ टी है ये आपका एफ टी है. दिस इज द फोर्स ऑन द ड्रम, दिस इज द फोर्स ऑन द ड्रम. ये फोर्स आपका ड्रम के ऊपर होगा. तो एंटी क्लॉकवाइज है, तो मैंने आपको बताया जिधर आपका डायरेक्शन होगा, जो लीवर के ऊपर फोर्स एक्ट करेगा एफ टी, वो इसकी सेम डायरेक्शन में होगा. सो दिस इज योर एफ टी. So this is the direction of Ft, right? In the anti-clockwise direction, this is the direction of Ft, and this force which I have written here, this is the force on the drum, force Ft on the drum. But we don't need this force because we are taking the forces on the lever only. I have not drawn here the free body diagram. So only the forces which are on the lever or on the shoe, only we are taking that force. We are not taking the force on the drum. So this doesn't require. So only this Ft, this force Ft, this normal actions, normal force, and this is P. These three forces are there. Now again, now you see the movements of this. Again, you will see the movement of P. This is in the clockwise direction. Movement of N, this is your anti-clockwise direction, and the movement of Ft here, this is also equal anti-clockwise direction. J भी आपका anti-clockwise होगा और J भी आपका anti-clockwise direction होगा, J, right? So now the equation becomes, equation of the P becomes, क्या इक्वेशन होगा P का इन एंटी क्लॉकवाइज डायरेक्शन. सो हेयर यू से टेक सिग्मा m hinge, this is equal to 0, right? Take the moments about O, or take the moments about hinge O. Here you have seen that the force is passing above the hinge here. This is your hinge, and this force, frictional force, is passing above the hinge. So in this case, when the drum is rotating anti-clockwise direction, so in this case what happens, take sigma m equal to 0. So now the equation becomes P into L. So this is clockwise direction, P into L, this is clockwise direction. Now you come to this force. This force is rotating anti-clockwise direction because you are taking the moments about O. So this force is acting anti-clockwise direction. So this is, it means that anti-clockwise direction we have to take the negative sign. So this is n into A, and Ft is also acting anti-clockwise direction. So minus Ft means mu n, Ft means mu n into V, this is equal to 0. Ft mu n into V, this is equal to 0. So this is the equation of the, when we are taking the moments about the hinge, this is the equation. So from here you can derive the equation of the P. So what is the value of P? P into L. This is equal to, both will go to the right side. So it becomes positive. So NA plus mu N V. NA into mu N V. Therefore, P is equal to, you take N common, so N common, so this is equal to A plus mu V upon L. So this force from here, you say when the drum is rotating clockwise direction, here the more effort P is required, more force has to be applied. Braking effort is not as much as in case of anti-clockwise direction. So this brake is not self-energizing brake, because more effort we have to apply to rotate the lever, and the shoe has to be made in contact with the rotating drum to stop the drum. So this is the equation of this one. So today I have taken all the three cases when the line of action of frictional force passes through the hinge, and when the line of frictional force passes below the hinge, and when the line of frictional force passes above the hinge. So these are the three cases, and these are the design equations. This is very important topic. You must take care it clearly. You must try to understand it well. And tomorrow I will take the band brake. Thank you. So nice of you. Good evening to all. Thank you. किन्ना चिर तो आया? हाँ? किन्ना चिर तो आया? बंद कर दो. ला.